Hello everyone. So today we are going to start a new video, and in this video we are going to learn about the types of fraction. If you haven't watched the last video, it was on the introduction of fraction. What is a fraction? We discussed it about in that video. So if you want to go and check out the video, you can go and check out. So let's start today's video without wasting much time. Today we are going to do the types of fraction. Now, there are many types of fraction, but we will categorize them. We will categorize them according to their needs and according to the situations or circumstances they fit in properly. So, first of all, that we are going to do today is a proper fraction. Now, what is a proper fraction? As the name suggests, a fraction which is proper, right? Now, what does that mean? So I'm going to write F for fraction. So a proper fraction is a fraction where you will find the numerator, that is the number on the top, will be lesser than the denominator. That means the number in the bottom. The numerator will be less than the denominator. Now, how it works? Let's see an example. For example, we have 2 over 4. Now you see, in this case, the numerator is smaller than the denominator. See, it makes sense and it makes, let's see how it works. For example, if we have a box that has total of 4 sections, like 1, 2, 3, and 4, right? So if we have a box or a bar that has total of 4 portions, and out of these 4 portions, 2 portions are shaded. That is representing the fraction 2 by 4, right? Where the representation can be possible, that is a proper fraction. That is why the numerator is lesser and the denominator is more, right? Now let's come to the next type of fraction, that is an improper fraction. Improper fraction. As the name suggests, it's improper. So you know that what we did in proper fraction? A proper fraction is a type of fraction where the numerator is less than denominator, right? And this is improper fraction, just opposite of it, nothing much. So what should we do now? In this case, the numerator will be bigger than the denominator. Number on the top, that is the numerator, will be bigger than the denominator, the number that is in the bottom. For example, let's see 5 over 4. Now, if you will notice, see, the numerator over here is 5, which is bigger than the denominator, that is 4 in this case, right? Now, it is practically not possible to draw 5 over 4. Right? Because the denominator, that is 4, shows the total number of groups, right? Or the total number of sections that a fraction has, right? Now, if it has only 4 sections, let's try to draw the 4 sections. So 1, 2, 3, and 4. It has total 4 fraction. Is it possible to like show 5 or 5 on it? No, right? It's practically impossible. That's why it's an improper fraction. The more examples you can take, you can create anything like 5 over 2 or 7 over 5 or 9 over 7. In all these examples of fraction, you have noticed that the numerator is greater than the denominator, which is practically not possible. Is it though? But we will study about it later. But right now, you know that it's practically not possible, right? That is why it's an improper fraction. Also, the proper fraction can maximum make the value as 1. Now, what I mean to say is, the proper fraction is a fraction where you will see at most the number can be equivalent. The numerator and denominator can be equal at most, right? The maximum thing is that can happen is both the numerator and denominator can be equal. For example, let's say 4 over 4, right? In this case, both the numerator and denominators are same. That is representing this as 1, right? If both the numerator and denominator are same, it represents one whole, right? So a proper fraction can be less than or equal to 1, right? But an improper fraction will always be greater than 1. It will always be, now it will always be greater than 1. Then 1. And in improper fraction, it's always less than or equals to 1, right? Less than or equals to 1. Remember this thing in mind. Always keep this thing in mind that an improper fraction makes it more than 1, whereas a proper fraction makes it less or equal to 1. Now, let's come to the next type of fraction that we are going to learn today. It's a unit fraction. Unit fraction. The word unit refers to the basics, generally to the 1. Now, those types of fraction in which the numerator will always be equals to 1 and the denominator can be anything, right? The denominator can be anything, but the numerator will always be equals to 1. For example, 1 over 4 or 1 over 3 or 1 over 7. In each case, you can see that the numerator is always 1, right? So these types of fraction, we call them as a unit fraction. Now, let's move to like fractions. What are like fraction? Let's see. So here we have like fraction. In these kinds of fraction, the denominator will always be same. That means the number that is in the bottom will always be same. The numerator can be anything, x, y, z, but the denominator will always be the same. Let's see, x over d, y over d, or z over d. What I mean to say is, let's represent this in the form of numbers. So you can say that this can be 4 over 7 or 5 over 7 or 8 over 7, right? Those fractions where the denominators are always same, they are called the like fraction. And always keep this in mind, a like fraction can be decided only if there are minimum of 2 fractions, because we are matching the denominators, right? And practically it's not possible to match the denominator if we only have 1 fraction. Now, let's see the opposite of a like fraction, that is unlike fraction. That is unlike fraction. Now, what is an unlike fraction? It's just the opposite, as the name suggests. It's just the opposite of a like fraction, where the numerator and denominator can be anything, right? For example, it's not required to be fixed. For example, 4 over 7 or 3 over 5 or 2 over 6. In all these 3 cases, you have seen that the denominators are random, the numerators are random numbers, not any pattern you can see. Again, always keep this in mind. At minimum, at least, we require 2 of the fraction to identify whether it's an unlike fraction or is it a like fraction. Then only we can compare, right? Now, it's time to turn to the most important and the last type of fraction. That is a mixed fraction. Mixed fraction. See, have you ever seen numbers such as this, 3 over 1 over 4, or 4 over 2 over 6? Now, what it means, not 1 over 6, actually, yeah, 3 over 1 over 4 and 4 over 2 over 6. Have you ever seen these kinds of numbers or fractions? They are the mixed fraction. Now, how they are formed? How they are formed. So, if you have, like, if we just did the improper fraction, so it is basically formed when we solved out the improper fraction. Now, what does that mean? Remember improper fraction? Those fractions where the numerators are bigger than the denominators, right? Like 5 over 3 or 7 or 8 over 2. Remember these kinds of fraction which are improper? See, it's practically not possible to show these kinds of fraction while doing representation, right? But when you draw a representation of the fraction of an improper fraction, it is called a mixed fraction. Let's see how is it done. For example, let's take this number 8 over 2. Now, practically 8 over 2 is not possible because we have the total value, like we have the total portions that are 2, right? That you can see. But we can't draw it in one bar. But can't we do it in multiple bars? For example, we should, like, the total numbers is fixed, right? The total number of portion is fixed. That is 2. So let's just try to make more bars until we reach to 8 by dividing it into 2 bars. For example, I have made these 4 bars, as you can see, each in the portion of 2, right? Now you can see that if you count them all, 1, 2, 3, 4, 5, 6, 7, 8. See, this is the representation of 8 over 2. Yes or no? This is also showing the same thing. But as we, knew about fraction, that it's a part of something. But over here, there are many parts. So to make it 1, what we should do? We will write a 4 over here as well. A 4 over here will help us to know that there are total 4 bars out, and in 4 bars, the total number of portion in each bars are 2. And this is how we get 8. That makes it a mixed fraction, 4 over 8 over 2, right? Now, let's just try to make 5 over 3. Let's just try to show this representation of 5 over 3. So, there are total 3 portion in one bar, right? Let's try to make. So we have 1, 2, and 3 portion in one bar. See, this is 5, right? We are talking about 5 portions, but we have 3 only. Practically, it's not possible. So let's just try to make more bars and then we would fit in, right? So 1, 2, and 3. Practically 3, the total number of portions in each bar is 3 only. Now, if you will notice, this much of the portions are representing 5 over 3, right? So how can you represent this? We have total 2 bars, and in each bar, the total number of portions are 3, and we are talking about 5 portions out of them. So that makes it a total of 2 over 5 over 3. Now see, this is practically possible, right? That you have 2 bar, each of 3 sides, like 3 portions, and we are talking about only 5 portions of it, right? This is practically possible. So that is how we represented a mixed fraction or an improper fraction into a mixed fraction. Now, there are different ways to solve a mixed fraction as well that we are going to discuss in the next part. Also, we can convert this mixed fraction into an improper fraction again. And how can we do that? To do that, we will be making another video in which we'll be discussing about how to convert an improper fraction back to uh, how to convert a mixed fraction back to an improper fraction, right? So we'll be discussing the next video. Also, in upcoming videos, we will learn how to add a fraction, how to add like fractions, or how to add an unlike fraction, what to do with a mixed fraction, and what to do with an improper fraction. We will learn about all the four basic operators, and we will perform it on different types of fractions. So that was it for today, and we'll be meeting in the next video. Thank you so much. Bye bye.